So the law of conservation taught us that, or basically means that energy isn't lost. It just transforms from one version of energy to another. But you know this to kind of not be true. You've seen certain examples where energy is lost. So for instance, when you kick a soccer ball, it eventually comes to a stop. It loses its kinetic energy. When you drop something, eventually it hits the ground. And after it hits the ground, it stops. What happens to that energy and where does it go? So it basically leaves the system and becomes a different form of energy. So it's no longer mechanical, but you know mechanical energy is just kinetic and both types of potential. Technically it includes elastic. We just don't do math with elastic to make it easier. But are those three types of energy the only types of energy that exist? There are lots of different types of energy, and this is my favorite example, is solar energy gives energy to plants, and sometimes plants we turn into fire to heat us. Heat is another type of energy that you see very frequently. But sometimes we convert chemical energy to a different kind of chemical energy when we eat it, and that can help us produce kinetic energy to move our muscles and things like that. So it leaves the system and becomes a different form of energy. These are some of the different types of energy you could experience, and we will talk about at another point later, at least electric and sound we'll talk about. But heat is definitely another example that you use most frequently. So I have another little illustration animation here of this guy going down a hill. You see total mechanical energy stays the same, potential converts to kinetic. All of that stuff is still true, but what happens when he hits this kind of rough snow, this unpacked snow? All of the types of energies are disappearing. He's losing kinetic energy because he's slowing down and his final velocity ends up being zero. He eventually comes to a stop. So at first you're going to notice the mechanical energy is not changing. He hasn't lost any energy, but when he hits that snow, this W bar ends up lighting up. It's underneath zero, so we can assume negative work is being done, which means energy is being taken out of the system. What force could be causing this work? Well, unpacked snow has more friction than packed snow, so we are going to call this a frictional force. And since he's moving this way and frictional force is acting the other way, we know negative work is happening, causing him to lose that energy. But where did the energy go? According to conservation of energy, he hasn't lost any energy. That energy essentially transforms into heat. Think about friction, and I think there was a lab called Field of Forces a long time ago where you rub your hands together. What happens, or what kind of energy can you feel radiating off your hands when you rub your hands together? It turns to heat. So energy isn't really lost, it just moves out of the system into the surroundings or the rest of the universe as a different form of energy. So this is still this idea of conservation of energy, it just may not stay within the system. So when something falls and hits the ground, I'm sorry, these used to be really cute GIFs and they kind of whatever, but Peter essentially jumps into the chair and stops. But when something falls and hits the ground, it becomes sound or heat energy, and it'll either heat up the ground or the object, or it'll make a noise, and it'll travel to our ears as sound. And when something slows to a stop, a lot of the times friction is involved, and it becomes heat energy. So when you see that energy has been lost, it's lost from the system, but it leaves the system as something else, as another form of energy. So big ideas, when energy is lost, it moves from the system to the surroundings. It's still in the universe, just existing as something else. Total energy in the universe never changes. So even the sound energy goes to your ears, and if you're familiar with anatomy, it kind of vibrates the little ear bones, so you can perceive that as sound, and it converts to something else. But total mechanical energy, since mechanical energy is just comprised of potential and kinetic, it doesn't always have to be potential or kinetic. It could be something else that's not just those two types. So total energy in the universe never changes. But total mechanical can change because it can be another version of energy other than just that. As energy change is caused by forces doing work, remember any change in energy is equal to how much work